Good morning, everyone. I welcome you all for this artificial intelligence in petroleum industry. We are going to discuss about new topic, that is cluster analysis in machine learning. So, how best it is going to be helpful for petroleum industry, we are going to discuss with that also. In this presentation, we will explore the exciting world of cluster analysis and machine learning, including different types of algorithms and their applications. So, first of all, I would like to briefly introduce what is cluster analysis. Why this particular topic came into significance in this real-time world applications. It is not just about one industry, it can be applicable to number of industries. Let us talk about what makes it to be into this particular domain. So we need to understand where exactly we are going to use this domain, like this particular concept, uh, so that we can get the maximum benefit of it. So it is a kind of unsupervised learning. Why? Because we are going to understand uh, the data which was not earlier known. Like we don't know when a random data was given to you. So if you don't have any idea of one point to another point, like if they both are not related to each other, imagine if you take a data like in ascending order, then there is no point of using cluster analysis. Either descending order, no need. If you have any logical relation between one point to another point, then there is no use of, like, we don't need cluster analysis for that. But if certain random points were there, they were kept on axis like xy axis or three-dimensional axis. So one point to another point, they don't have any relationship. Like you can't find out relationship by analyzing the data. If that is the case, we have to go for cluster analysis. So what do you mean by cluster? When a group of segments or points, when they are together, we name that as cluster. In space industry, stars, galaxies, cluster of galaxies are there. So what do you mean by cluster? Means there could be some attraction between one point to another point, but we don't know what are those points. But there are, when you look at it, we can't distinguish certain points which belong to one cluster. uh, Another point will be related to another, so we can't able to distinguish between like that. But once you do this cluster analysis, we can finally come to a conclusion that certain points are having somewhat affinity towards other points. So this is a kind of cluster that have been adopted. Like every point some or another way it is related to other points. If you find that relation, it could be difficult when it comes to million points, 10 million points, like that. But we can do for nearby 5 to 6 points, we can do it. But when it comes to million points, how to find a logical relationship, we can't. It's practically, which is not possible. So for that reason, we can do one thing. We can create clusters. Okay, certain clusters with the nearby uh, points and far away points, we can able to find a relationship between them. When you talk about a cluster, clusters look like spherical shape. In that spherical shape, certain points will be inside. A spherical shape will be having a centroid. So centroid is the center part of the cluster. So that could be any point of your random data. So you can take any point and you can convert that into a cluster. So that also we can do. So let us see how the algorithm works on it. So when you construct a cluster, center point, centroid will be there, surrounding number of uh, uh, data points which are close to it, which are away from it, but that should be inside the cluster shape. Imagine if these points are away from the cluster shape, they don't have any kind of relationship between this cluster and the points which are away from the cluster shape. So that points might have been into another cluster. So we need to finally we need to make all the points to fall into different clusters. Sometimes what happens is clusters will change. If more and more randomness is there, you are supposed to give more number of clusters. So if you quantify, let us talk about 1 million points, that means 10 lakh. So you can convert this 10 lakh clusters into 1000 centroids, so 1000 clusters, sorry, 10 lakh points into 1000 clusters, and each cluster will be having one centroid. So certain points will fall into one cluster, some other points may fall into another cluster. So first of all, we need to define what kind of, some points maybe very few points may fall into one cluster, but bulk of points might fall into one cluster. So we can't say which point belongs to which cluster. So this, we are going to do this analysis. We have softwares like Python is one of the most suitable software to find out cluster analysis. I mean, we have different types of clusters are there. We can do analysis in Python, even in MS Excel we can do. So we're going to see how this cluster analysis will take into picture. So introduction to cluster analysis. Cluster analysis is a method of grouping similar objects together in order to facilitate their analysis. It has applications in wide range of fields, including biology, marketing, and computer science. So marketing, when it comes to marketing, segment of people, like when you're trying to sell a product, you might target certain people. Why? Because those people alone will take more and more orders when it compared to other people. So you need to find out that kind of cluster, that kind of segment. This is possible with cluster analysis. When it comes to biology, we are not related to that, but we know so many areas are there. uh, Neurons, microbial species. So when you are distinguishing different species, so cluster analysis, why? Because it depends on its behavior, characteristics, nature. So based on that cluster analysis, you can identify this particular insect or animal belongs to a particular species. When you are defining a species, you have some characteristics, so that similarities will be cross checked, and based on that they will cluster these microbe species into that. So you have like this a number of areas we can able to concentrate. What is cluster analysis? Cluster analysis involves grouping data points and clusters based on their similarity to each other. So it's simple thing. It is not it depends on what is that you are expecting from this outcome. You might be expecting properties similarity or characteristic similarity or color similarity or density similarity or molecular weight similarity. So it could be of anything like reservoir property similarity like porosity, permeability. So permeability similarities may, certain permeabilities which belongs to certain rocks might fall into one cluster. In the same way, for other similarities of permeability of other rocks may fall into another cluster. So first of all, we need to understand what kind of similarity that you are pursuing for. Why? Because we, based on that itself, we need to cluster the data, like whatever, whether it is related to lithology or microbes or whatever discipline it could be. So cluster analysis is going to be applied in different sectors in coming days. So this is one of the huge advantage of machine learning. Like why? Because we can distinguish different areas or disciplines or properties or based on this cluster analysis. What are the applications of cluster analysis in machine learning? It is often used for image segmentation, outlier detection, and face recognition. See, when it comes to face recognition, which is a security trait that most of the companies might follow uh, right now, also say face recognition. Why? Because when it comes to cluster analysis, it has its own definition. Like a cluster might have its own characteristics, own properties, and all. If it matches only, it will allow that to fall into that cluster. So that can be applied for face recognition, which is an important thing for banking sector and other areas. Then other thing is image segmentation, like image, like when you see an image based on each segment, so image will be having different segments. So more and more segmentation, the image will become more and more sharper. So when you use cluster analysis, it will give you very clear idea about this. Like imagine you have taken a photograph from satellite, you are observing, land area over there. So with the help of cluster analysis, you can pinpoint where the water might have flown, where the terrain areas are there, where the mountains are there. So all these things can be easily understood if you have taken a picture from satellites. So satellite images we can clearly, we can deeply, you can magnify through this cluster analysis. We can able to get some very good outcomes and insights related to that. So when it comes to detecting other objects, so outlier detection. What do you mean by outlier? Outlier is something beyond the limited range. Like you might have a limited range, you might have specific range, you are targeting about certain places where the height is around 200 to 300 feet. So 400 feet, like imagine you fixed that I want to find out locations for uh, 400 300 feet, not above that, below 300 feet only. So this outlier values will be above 300 feet. It could be 400, 500, 1000 feet and all that. So how we can able to find out these outliers? Like when you start using cluster analysis, it will specify the areas only where it comes under that range. So imagine if you're targeting around 300 feet means it is going to show you the images which are related to that particular range alone. So this is going to be helpful. And what about research? It is an active area of research with new algorithms being developed all the time. So in research, it has been used for algorithms. Like we are going to use this for research also. Like a lot of survey data will be there that can be used for clustering. So types of clustering algorithms. There are many different types of clustering algorithms, each with its own strengths and weaknesses. Some of the most common used including hierarchical clustering, k-means clustering, and DB scan. So we are going to discuss not all the clustering. We are going to discuss about hierarchical clustering and k-means clustering, about their algorithms. DB scan is out of the scope currently, so we are going to focus on hierarchical clustering and k-means clustering. So first of all, today's session we will be more concentrating on hierarchical clustering. Then we will go, for k-means clustering next. So what is the first of all, we need to know what is hierarchical cluster, and another thing is what is k-means clustering. So hierarchical cluster is like based on the distance between different random points, you are going to make it as a cluster. So you are talking about distance, like imagine the points which are close to uh, that particular area, then we can consider that the properties might be more similar if the points are away from the particular point data. Like imagine there is a centroid in a cluster, the points close to centroid might possess similar properties which a centroid have. So the points which are away from the centroid, if it has some distance but still falls in the cluster, then they may not able to possess the way how these close points are possessing. So in that way we can able to define. What about the points which are totally away from the cluster? They don't have any significance or relationship between their properties towards your centroid. So centroid can be acted as a center part of the cluster, where it acts like a reference, like you know the kind of reference that we have, like midpoint, average point. So from that point, the points which are close to the midpoint or center points may possess almost the same kind of behavior. Up and down, that has to be adjusted. Based on that, you can define the value. You can upscale it, downscale it. It depends on the points which how much close towards that centroid point is. So how we can able to define this centroid? So we're going to see that when it comes to k-means clustering, it is not the case like hierarchical. So what we will be doing is, first of all, we need to define based on, in cluster like hierarchical cluster, you don't know how many clusters it is, but based on the points you are going to make clusters. But when it comes to k-means clustering, you think that this data might fit into specific mean of clusters. Okay, so we have a graph to define how many clusters that might be required to fit the data into that. So after that, we are doing is we are going to select one point in the cluster, and we will try to make this point to become a centroid. Okay, so what we will be doing here is we are going to fix clusters. Imagine they have given you around 100 points. So what we feel is three clusters might be enough for that. So first of all, we're going to fix the cluster, and after that we will select a point at somewhere around the data points. Three different points will be taken, and what we will be doing is from there onwards we will try to make these points to become centroids of a cluster. That is what k-means clustering is all about. So hierarchical cluster is not like that. Hierarchical cluster is simply like based on the points how many you have, we transfer that points into becoming to a cluster. Okay, so for that we need distance value. We have different types of distance values that we have. Euclidean distance, this is the most common distance measure suitable for data with a defined magnitude. Manhattan distance uses the sum of absolute differences instead of square differences. So square differences we are going to use in Euclidean distance. Min Minkowski Minkowski distance allows the user to choose the degree of distance calculation. For example, when p is equal to 1, it is Manhattan distance, and p is equal to 2, it is Euclidean distance. Minkowski. So this is how we are going to pronounce. So it is having a different kind of pronunciation. So Minkowski distance. So this particular distance is ideal for Manhattan and Euclidean. It depends on the value of p. If p value is equal to 1, then Minkowski distance will become Manhattan, and when p is equal to 2, this Minkowski distance will become into Euclidean. So we will be seeing the difference. So when it comes to Euclidean, this is the formula that we are going to use. Root over summation of I is equal to 1 to n and qi minus pi whole square. So after that it is summation, like it how many data points that you have. It depends on the value of n. So imagine you have 3 points q1 to q3. In the same way for p1 to p3. So like that it will continue. So this is about Euclidean distance. So when it comes to Manhattan, there won't be any square root. So from the difference between Euclidean and Manhattan will be square root and square will be removed. So you can see there is no square root above. So here we have square root and square that have been removed simply. So then it will become Manhattan distance. So these two are somewhat important, but most important one is Euclidean distance. Then let us come to Minkowski. So when it comes to Minkowski, uh, there is an ideal formula that was there, qi minus pi power p whole power 1 by p. So if this is the case, if the value of p is equal to 1, then this becomes Manhattan distance. Why? Because 1 by 1 will be 1. So what will happen? This is how the formula looks to be. So if the p value is equal to 2, then qi minus pi powers 2 will be square, whole power 1 by 2 will be root over. So that looks to be Euclidean distance. So it depends on the value of p that what you are taking. So Minkowski is like ideally it is related to either Manhattan as well as Euclidean distance. So it depends on the value of p. If p is equal to 1, it will be Manhattan, and p is equal to 2, then it will become Euclidean. So we are going to use mostly Euclidean, and let us see how these values will be helpful. So evaluation of clustering results, quantitative and qualitative methods can be used to assess the quality of clustering results. Some common methods include Silhouette coefficient, trustworthiness, and visual inspecting the results. So Silhouette coefficients, a measure of how similar an object is it to its own cluster. compared to other clusters. So you can see a small diagram of this example. Let me just expand it. So we have different points with different cluster. Can you see they have like black, yellow, green, sorry, blue, and green. So we have different points. Earlier without these colors, they may look almost same, but after giving some colors, so these cluster points will be easily defined. And if you could see the values of these clusters, they have been given some dimensions over here. So might be the black one might have more number of points compared to the orange one. So it depends like how the clusters, as I said earlier, some points, very less points may fall into some cluster. Maybe around 100 you may have a cluster of, imagine if you subdivide 100 into five clusters, each cluster might have 20 20 20 divisions. Like first cluster should be 20, like that all the five clusters should have 20, but it is not like the case. Cluster means the similar points will fall into one cluster. So maybe 40 points may fall into first cluster, other cluster may have 5 points. So it depends. Why? Because these 40 possess similar results, so that only you are going to cluster them into one point. When it comes to other cluster, you may not able to do that. Why? Because it depends on the kind of similarity that it has. Okay, this is how we can able to find out different clusters. Trustworthiness, a measure of how well the clustering reflects similarity relationships in the data. So as you can see, the data was given the trustworthiness, like how much you can able to depend on the clusters that we have. So here we have different classes that we have, and the points what we are seeing are random, and how much you can able to rely on that. So cluster analysis will provide you good trustworthiness, but it is not that simply you kept the points over there, but they possess similar values. You can just rely on this cluster analysis so that you can able to start calculating for the further areas by using this cluster analysis. Visual inspection, inspecting the clustering results to check that they make sense. So when you start testing these clusters by visually, then you can able to get the results, like it may provide you accurate results. So accuracy is very good when it comes to hierarchical cluster, but it all depends on how you're going to cluster them, like what kind of points and what are the points that you are going to fit into your clusters. Applications, so image segmentation, grouping pixels into different segments can help the image analysis and object detection. So we already have cameras in our mobile. So cameras earlier when they were being in developing phase, so generally we used to have a megapixel, like around 1.3 is a megapixel for a basic level camera. So that that is one kind of cluster. Like if you talk about cluster like image segmentation, so 1.3 megapixel means your whole image will be filled with 1.3 million pixels. So this is how the definition looks to be. So but when it comes to increasing this megapixel, then you can start having an idea that the vision is becoming more and more sharper. Why it is becoming more sharper rather than 1.3 megapixel? Imagine you have taken around 40 megapixel. So the time of segmentation, like the multiple ways of segment, like 40 times more than 1.3 megapixel. So mega represents 1,000, 10,000. So that many squares have been subdivided over there. So this into 40, so that will give you 40 megapixel. So you can able to easily understand what is that image, and the clarity of outliers and everything can be easily seen if you are having more and more megapixel. Today we have around 40,000, 4,000K pixels are also there. So more and more clarity, if you zoom it also, you can able to see clearly the areas of what you are focusing on. So this is about image segmentation. Anomaly detection, like when it comes to anomaly, mostly we will be talking about seismics. So seismics, we have different pattern. Like when you see a seismic map with your naked eye, you cannot able to detect any kind of anomaly. It requires a lot of experience. You might require most of the knowledge to understand this kind of anomalies. But if you put it in a system where cluster analysis was done, so clusters were already encrypted with certain data which belongs to these anomalies that can easily detect seismic anomalies, and based on that you can interpret what could be the possibility of location feature that you may able to encounter. So marketing, we already discussed about this marketing thing, and then different lifetime examples like flower classification, retail customer behavior, document clustering. So we can use it for anywhere. So conclusion, cluster analysis is a versatile tool that has applications in many different fields. As machine learning continues to evolve, new algorithms and techniques will continue to be developed, leading to even more exciting applications of cluster analysis in the future. So, future prediction, as technology advances, cluster analysis will become even more important for data analysis and decision making. So, when it comes to conferences, there are many conferences and workshops devoted to the topic, and it has an active area of research. As more data is generated and collected, the potential applications of cluster analysis will only grow. As they can see, a lot of data that has been using this technique, but in future also we have good scope for this cluster analysis. So let us, after this, let us get into the algorithm that we are going to just discuss. I'm going to open MS Excel sheet, so you can see there are few points. If I start, like you can see, pressure point is there, x-axis, y-axis. So I'm going to take it to top. So you can see, what to remove this. So let me just clear this colors that I have already. So condition clear forward, clear the rows. Okay. So I'm going to zoom these values. So you can see these are the, sorry, zooming the values, and you can see clearly what are these values are. So pressure points are there, P1, P2, P3 up to P6, x-axis, y-axis. So let me just show you these values in a normal graph, how it looks to be. So you can see there are like different, we don't want line graph, we just want uh, this graph. But rather than this, what I will do is I will just go to recommended charts and go to the graph, and this is actually the graph which I'm looking for. Why? Because based on x and y axis this graph have been subdivided. So this is how, but by seeing this we can't say what cluster will fit into what area. Like if you want to increase its say, let me just check out bubble points. So these are the points, like in a bigger size these bubbles are showing you, but we don't know what points. Maybe these 3 points are close together, so you can fix this onto a cluster. So but we can't, like you can see the points, when you change the size it is changing. So you can take this as a cluster. Maybe this one and this one might be closer to this here, and this one is totally away from it. So we don't know, like these two clusters belongs to this. Sometimes what happens is these three may be related, and these three might be related to this one also. So we can't say which cluster is like all the points, how they are related. We don't know the relationship between all this. So right now we are going to find out how to find out this relationship. Okay, so let me just keep this beside. So this is a point that we have. Just we will keep this beside, and we will try to construct a small table. So I will be writing that as pressure points. So we have P1 to P6. So P1 P2 like that up to P6 in the same way on horizontal way also. P1, P2 like that, just to go ahead up to 6, P1, P2, 3. So this is how algorithm of this cluster analysis we are going to construct. So I just kept all the tabular values over there. So we need to find out Euclidean distance between each points. Like imagine I'm going to put the value of Euclidean distance over here in between P1 and P2. So when it comes to here P1 and P2, P1, P1 the same distance. So same distance Euclidean distance will be 0 only. Why? Because the same point you are finding out the distance where the location is same, so it will be obviously 0. So in that way, uh, certain points which are having similar location will be 0, and we need to find out Euclidean distance for other points which are connected to them, and based on that we have to find out the least Euclidean value next to the center point. Then we need to cluster that value with the corresponding point. Okay, this is how we are going to see, and I'm going to just take this graph somewhere around here. Why I'm taking this you will be knowing very soon. So let me just zoom it, zoom. So this is the point and this is the table. Okay, so this is the point. I will take it even more closer so that will be better. Yeah, you can refer it easily in one screen itself. You can refer. So this is the reference table and this is the point. Okay. So P1 to P2, I'm going to find out Euclidean distance. So Euclidean distance form is square root of x1 minus x2 square plus y1 minus y2 square. So square root, I will be writing it as SQRT. So square root of x1 minus x1 whole square. So x1 is this, and I will start with simple. Why? Because we are having two values, so I will start with another bracket. So x1 minus, in this case both are same, x1 minus x1, the same points, whole square plus, open the bracket, y1 minus again the same y1 into whole square. So the answer after entering you will be getting it as 0. So why it is yellow means I haven't removed the conditions. Okay, so the answer is 0. Okay, so this is about your distance between P1 and P2. So when I have to measure the distance of P2 to P1, this formula will not work out. If you start dragging it, you may get all the values as 0. So you can see everything is matching with the same values. So if you are confused with the color of this table, I'm going to just remove this. It's easier to. Okay, so just see these two we were selecting, but when you start working for the second one, it is selecting the same. Why? Because we need to find the distance between P2 and P1. So this is going to select the same. For here, what I'm going to use a trick is, so I want to log the values of when you're going down. So P2 minus P1 means this first value has to change. So I'm keeping the first value as a variable and the second value I'm converting that to a constant value. The same way I'm doing it for the other value also. Equated the same answer. Right now I'm going to double click, so you can see you have different values that we got. So this is how we can able to estimate the value between P2 and P1. You can double click on it, you can see the values of P2, 0.5 minus 0.3 whole square plus zero point 0.4 minus zero point 0.3 whole square. So like that it will start working on all the values. Okay, so we got this one. Then next step is, don't just start working on the same way how we have started with the second column. So we should not do that. Why? Because P1, see, imagine if I start working on this, what would happen is, so it dragged up. drag to top. So, but actually what is the value of this? If you adjust the values, should be equal to P2 and P1 only. So P1, P2 is equal to P2 and P1. So no point of working on that values. Rather, you go for the next value. Why? Because again P2, P2 onwards, here the values will change. So select that value and just drag the second value of it. So here click it. It was not adjusted properly, so you need to adjust it accordingly. So here what we have to do is, so this adjusted according to Excel rule, but here it should be in between P2 and P1. So P1 values it was taken. So for that what we have to do is just select these values to like this, and just select the first value over there. So and click enter. So you got 0. So P2 and P2 the 0, and double click on it. So you got all the values of it. So you can see, if you double click on it, you can see how P3 minus P2 came when you have just when you have this one, P4 minus P2. So this is the logic that we need to follow for all the points. So leave the first value, go for the second one, just adjust to third and adjust the values over here. So not here, third value, and second value, third value, second value. Just enter it, double click on it. Then go for the next one, double click on it, enter, do it again, enter, go for the last value. So generally, as you can see, diagonal it is 0. So obviously this value was supposed to be 0. It has to be 0. Anyway, we will do with our traditional. See, we have confused. Yeah. So this is the order you are supposed to go. So it haven't come to 0. So there could be some C7, B7 came. So C7 should be equal to C7 and B7 should be equal to B7. So then we came to 0. So after selecting all these values, the second step is to find out the least value of this. So if I start searching like 0 0.3, 0.35, 0.25, it would be a little difficult. So for this, we have an Excel function to find out that. So let me select all the, but you can see the least values are becoming, definitely the values are 0. So consider this 0 as a text value. So we don't want that. Apart from this values only, I need to get what are 0. So just convert all the 0 values to be text, select the data, and you are supposed to find out the least value. Go to conditional formatting, go to new rule, go to, not new rule, this conditional formatting, go to highlight the cells from bottom 10. And here what I will do is, I don't want bottom 10, rather I go with 1. So this is my least value. So it is in between P3 and P1. So P3 and P1 are clusters. So this is how we can able to understand. So first cluster is P1 and P3. Okay, this is your C1, cluster 1. Then after that, what we have to do is, we already fixed the condition in the data. So the only thing is we need to remove the data, and before, just remove the data at P3 and add here as P3. Why? Because we have clustered that value there. So we have clubbed that value to P1. So P1, P3. So let us see for the next least value. So next least value was showing to be at P5, which was connected to P3. So P5 has to connect with P3. So P5 after P1, P3 was already clustered with first one. So you need to add one more point to here. So just to make that point as P5 and remove the value of that value. So you remove. Then again, P4 is clustering with P2. So just select the value P2 and P4 and remove the value. Then P2, P4 is clustering with first value P1. So right now what you have to do is you need to close this. Actually here we have two clusters. So first cluster is P1, P3. After that P1, 3 have clustered with P5. Then after that P2, P4 have become cluster. Then right now P2, P4. So this has to be kept over here. So you can already see P1, P3 have clubbed to P5 and P2, P4 is clubbed to P5. Sorry, P1. P2, P4 is clubbed to P1. So not P5, but which was already been there. Okay, nothing to worry about that. So let us remove P2, P4 also. Then P6 is clubbed to P2. So P2 is here. So finally, comma P6 will be clubbed to P2. So this is how it looks like. So first cluster is P1, P3. These both have been clustered to P5, and other cluster is P2, P4, which was clustered to P1, and finally P6 have been clustered. So P6 is the last one, and the first one is P1. So when you construct a dendrogram, so we say that as dendrogram. So how the dendrogram looks to be. So this is how a dendrogram looks to be. So let me just explain the I can remove this, not a, so you can see there are, I will just keep both at work. Yeah. So first of all, P1, P3 are clusters, P1 and P3. Then after that, P5 join to P1 and P3. Okay, this is how the cluster have connected to, and P2, P4 have connected to P1. So P2, P4 are separate clusters which were connected to P1. So they have been kept separately and joined to the cluster which was connected to P1. So P1 directly can't be connected, but whatever the cluster which is close to it, it has been connected. Then at the last, the cluster is P6, which was connected to your P1. So from P6, wherever the cluster relation is there, that you can able to connect it. So this is the distance, this is the pressure, and this is how hierarchical cluster dendrogram can be generated. Okay, this is a dendrogram, so which is very important when you are estimating the value of these clusters. So this is about MS Excel, how we can able to define cluster. But let me take to another software which will help you to create a dendrogram like this directly. So if you have to do with algorithm, you have to follow this procedure, but since we are into artificial intelligence, we have some benefit over software. So let us start working on that. I have selected the data in Excel sheet. So I'm going to use Chat GPT. So let me just go for Chat GPT. Here I kept the values and I'm going to ask it to generate dendrogram through Python. And on the other side, what I will do is I will open the Python environment. Uh, So let me, it already given me the code. So you can see SciPy cluster hierarchy. So this hierarchical cluster, this is the one function that they're going to use. It's a machine learning function. So you have to put the value over there and ask it to construct a dendrogram. So just to select the code, paste it, then enter the value. This is the Python code. It is using SciPy cluster hierarchy is the one, and NP for calculating the values which are inside that, like Euclidean distance value was there. So you can see the dendrogram was constructed a bit different, but almost the same. So P1, P2, so we haven't given P1, P2 value. So that is the reason it was giving you like that. But you can start working on P1, P2. So P1, P2 values were not taken into the graph. So let me just check out. So P1, P2 are there. Let me just give, I have written this wrong, but it's okay, fine. So again, it is giving the same code. So with the generate dendrogram through dendrogram for pressures through Python code. Python pressure points P1, P2 points. Okay, that is enough. Manipulate P1, 2, regenerate. Yeah, right now it is taking P1 values. Okay, copy, and let us keep the value as it is, and we will try to estimate uh, so this is how P1, P3 connected to P5, which was connected to P2, P4, and finally it is P6. So this is how a little modification is there, but this can be taken into picture since the data what I have given constructed that dendrogram is not the same. So this is the main data I took it. So I'm going to use this dendrogram, not this one. So here a bit different is there, but this is the one which we can use it to estimate the values of clusters. So you can see this will fit exactly. Why? Because earlier dendrogram points are different, so that I just shown you for, as a sample, but these are the points that we took it. So you can see first of all P1, P3, P1, P3 was selected, first one, it was clubbed to P5, so P5 was clubbed, and P2, P4 a separate cluster, so this have been clubbed to P5, that is here, and finally all together it was clubbed to P6. So this is how the dendrogram looks to be. Okay, so in this way we can able to construct dendrogram in hierarchical cluster. It is a very useful, like it is not just about these points. If you can give around so many, like 100 points, 1,000 points, it depends on the variable data. Based on that, dendrogram can be constructed. So thank you for today's session, and we can tomorrow we will be meeting for data analysis, and have a nice day. Thank you very much. Bye.